Welcome everyone and be welcome to this edition of the Safety Footwear Revolution Week. We are very pleased to invite and delighted to have this set of people speaking and sharing the ideas with us in this panel. We are also very grateful to the huge number of people that have been helping us achieve this result. People have been inscribing themselves, sharing ideas, sending their questions, and we were very positive with this. Our objective, as we had explained, was to broaden as much as we can this convention, this panel, so everybody can help us to think about the future of safety shoes, to think about the future of the production in Europe, and to think what we can do differently for the future, being on the environmental level, being on the technical level. So here I would like very much on this panel to share a thought with you. We have seen in the past in Europe and also in the USA, some presidents sometimes sharing big goals that almost seemed not possible to achieve. President Kennedy in the United States with the let's go to the moon, Georges Pompidou in Europe when he said, let's make the Concorde, let's make the TGV. At the time, those things were not possible to be achieved. They had to change the mentality of the peoples. The universities had to adapt. The industries and the schools had to adapt. But 30 and 40 years after, we can see the transformations these big projects have brought to the United States and have brought to Europe. Well, I believe in our sector, in shoes, the technical footwear is always also the first comers. We are always the ones pushing the boundaries and pushing the limits with new materials, better performance. In this panel, I believe we have with us some of the most clever and cheerful guys that we like to share with us some of their thoughts. So thank you so much for coming. And I will invite everyone from you to make a short presentation about yourself. Perhaps we can start with Mr. Ambrogio Merlo from JV International.
Yeah, with a pleasure. Good morning to everybody. First of all, I would to clarify that I represent JV International. JV International is the Michelin exclusive worldwide licensing company for development, production, and sales of Michelin technical soles. Then it's very important, if you need Michelin technical soles, you have to call JV International. Otherwise, you don't receive soles, but you receive tire from Michelin.
Very well, thank you so much. Perhaps I will jump now to Mr. Rüdiger Fox from SYMPATEX.
Thank you, Pedro. Yeah, hello. My name is Rüdiger Fox. I'm, as a job assignment, the CEO of SYMPATEX since a couple of years. But having spent many years in various kinds of industry, I would rather say I'm kind of the curious discoverer of trying to identify what the future brings. So the one is a role, but the other one is the passion. And I think that's more important.
Thank you so much. From the other side of the Atlantic, we bring a different perspective. Early morning, Professor Kurt, that has joined us. Professor Kurt has been, we met Professor Kurt in some technical reviews, some technical press on the World Footwear pages, and we were enchanted with the quality of the work he was bringing. Can you explain a little bit about yourself, Professor?
Yes, thank you. First, I'm super excited to be part of this panel. So I am an associate professor of bioengineering at the University of Pittsburgh. And as part of this job, I do research on footwear and try to understand the mechanics behind footwear friction so that we can connect tread design to friction performance.
Adrian, can you tell us a little bit about yourself and about your company, Simplicity Works?
Yes, of course. Hi, Pedro. Well, As you probably know, I am Adrian Hernández, founder and CEO at Simplicity Works. Simplicity Works, a company that was born thanks to an idea. Before was a wish to do something for the industry, to promote a change in production and a change in logistics. My background is industrial engineer, working in our industry for many years, and have been experienced during this time the understanding and learning of different manufacturing process, and working in operations in the footwear, actually suffering in my own skin the complexity of the footwear industry in several fields, in management and operation manufacturing. So in a moment of my life, I wanted to do something in the way of simplifying the production process, and therefore allowing a new economy, a new profile of companies that could be able to produce footwear locally. So in somehow with this project, we want to shorten the distances between the manufacturer and the consumer.
If I could start, I would like to pose a question to Rüdiger Fox from SYMPATEX. I believe you have been able to think a little bit differently on existing materials. Actually, what SYMPATEX has done is kind to reinvent layers of functionality over existing solutions. And this is bringing and pushing the boundaries of the shoe production, sometimes even in Europe, further. Can you give us a little bit what are your goals, your visions for the future?
Yeah, I can try. And I have to apologize if an aerospace engineer comes into the shoe industry, he comes in with some crazy ideas, and probably not all of them will work in the long run. But my background is very much lean production, automation in automotive and aerospace. So when I joined the industry, I was just amazed on one side what high performance we can achieve in our industry, and on the other side, the industrial level we were able to achieve to the day now for serious production. So our key goal was, on one side, going straight forward in a vision of automatization in the production process that goes hand in hand with a very high quality level on one side. And on the other side, we feel we are strongly driven by that conceptual idea that at some point all industries need to avoid leaving traces and damage in the commons around us. So we were looking at concepts which on one side drive automatization, and on the other side find a very close material circuit that at some point could go into circular as a prerequisite. So we researched a lot whether the traditional way of manufacturing waterproof inner shoes could shift from a manual production into thermoplastic deformation, which is kind of a well-known technology, but has never been used in our industry. And how, with the right combination of the textiles, the protective textiles to the shoe, the abrasion requirements of our industry, the different kind of mechanical designs could work together with a monomaterial concept on the laminate that can be based on a polyester, can be thermoformed and turned into an automatic process.
Thank you so much. It's curious, Rüdiger, because I also share this passion about the automatization that we should bring to shoe assembly. Mm-hmm. Curiously, I have the feeling that in the beginning, a lot of people were looking at this automatization as a way to become competitive. Let's say that we saw some Asian countries where labor was cheap, and typically we thought, how can we automatize those functions? But today, we see that automatization is not going to be a tool to fight among two continents. That's not the goal. And I believe that you have really pinpointed out correctly what your idea. I would like to turn our attention a little bit to Ambrogio Merlo and to Professor Kurt, because they work in the basis of the shoe. The outsole is the chassis of the car. The outsole is the base of the shoe. Not only about the formulation, also about the design, and also about the function that we want to bring. Merlo, Michelin has been exploding in the market. We are all seeing your outsoles out there. We see them on LinkedIn. We see competitors on the track field starting to wear them. We see people in the runways, guys in the motorways. And I believe you must have a lot of experience in your back, having the Michelin team supporting you with formulations. What do you aim to bring to the technical footwear market?
As you said, our mission is to transfer the technologies coming from tire industries, especially the concept that give performance to tire. Our mission is to transfer these technologies to soles in order to give in every field the top performance that we can achieve to give a completely different experience to the final consumer. As you said, we don't limit our intervention to some segments of the market, but we provide innovative solution for every area of the market. In this market, more and more, the final consumer become central in defining the development axis, especially if we are talking for safety footwear markets. More and more, if we think about the footwear market, the safety footwear market, the digitization has increased the visibility of the working safety product, increasing the customer knowledge of the available product in the market and of the technologies present in the shoes. The final consumer now knows what he wants to improve his wellness during the daily work. And regarding the products, protection now is a must-have, but the final consumer increased the sensitivity to comfort, lightness, grip, style, and performance in general by innovation. In the major part of these parameters, innovation in soles can give some advantages compared to what is present with what is already present in the market. But for the moment, I stop here because maybe I have some...
Very well. Very well. Thank you so much. Here, I would like to invite Professor Kurt to share a little bit what he has done. And more, this is a particular curiosity from my side. Professor, how has it happened that someone in a university in the USA has decided one morning that I want to study the performance of outsoles? What happened to you that day? What's behind that passion to develop a solution for outsoles?
Yeah, so I wouldn't say it was one morning as much as it was several years, but I think the reason that I have focused so much attention on footwear and its opportunity to prevent slip and fall accidents is the opportunity to make people safer. There is a lot of need for the research. It's a big problem. It causes, just in the US, hundreds of thousands of injuries per year. and there's a lot of evidence that footwear has a great deal of potential to ameliorate that problem, or lessen that problem.
Very well. Can you explain us a little bit how you have approached that topic, how you have thought about dealing with the issue?
Yeah, of course. And so, as the previous panel speaker mentioned, grip is one important component of footwear. And as this panel is aware, and as the audience is well aware, shoes need a certain level of friction performance or grip in order to be safe. And so, one goal of our research has been to develop experiments and models that go beyond determining the performance, but actually tell us the cause of low friction. So it's a set of diagnostic tools that can tell us why a shoe has low friction performance. And so one of those tools that we use is finite element analysis. And before I talk about that, I must acknowledge Syed Moghadam, or as he goes by, Pavand, who was a PhD student who was really central to developing these models. And so our finite element analysis models target a form of friction known as hysteresis friction, which is a kind of friction that occurs when a rubber-like material slides against a rough surface. And so our models do something called multi-scale modeling, where they model the origin of that friction, which happens at really small scales, micrometer scales. So it models that. And then it also models the whole shoe, and it kind of maps what's happening at the micrometer scale onto each individual tread at the whole shoe scale. And so a benefit of that is that it can help us determine which treads are beneficial, are helping us with friction, and which treads are harming us. So it sort of does two things. One, predicts the overall performance of a shoe before it's even prototyped, and two, it tells us the regions that would benefit most from redesign. And so it has the potential to reduce costs related to prototyping and engineering redesign, as well as increase performance. And so looking forward, I think one of the challenges that we're interested in is how do we take these tools and make them readily usable by the footwear industry? I think it's unrealistic to expect every person who designs a footwear tread to be an expert in friction. And so one thing that we're interested in moving forward is how do we package either information or the tools themselves into ways that work with designers' workflow and that can be used by designers.
Kurt, I told you several times, I'm really passionate about what you have done, the way you have done, and I believe that in a short to medium term, we will see those kinds of tools being part of a kind of an Autodesk or Rhino pack, where the designers can start to design the outsole. Of course, they will have to achieve a certain degree of definition and cleat specification, but you will have a predictive tool in your software that is going to give you a kind of a green light. If you want to, this is for mountaineering, you are okay. This yellow, careful, you should improve here or improve there, or a red light, like don't go there. Of course, I do understand, as we have already discussed, that first you need to characterize very well the polymers and the rubber, their friction, so you have to build a database. But now I'm a customer. I am one of these brands, or I'm even Mr. Merlo, and I want to approach you and to say, look, my designers have done 5 finished designs. Can you assess? Let's put in a practical mode. How can I use your knowledge? How can I try to predict the behavior of my team design also with your software? Let's try to put this in a simple way, because we have here more than 1,000 guys looking to us. Half of them perhaps are designers, and they are eager to know, how can I interact with this tool?
Yeah, that's a really good question. And so I would say that there are two ways that designers could interact with the tool. And so one is that that the tool allows us to generate information and sort of a list of rules that a designer can rely on when making design choices. And so, for example, we found that using the model that beveling the back of the shoe heel is beneficial for friction. We found that removing texture from the surface is beneficial. And some of these things are known by others in the industry, but we've also found them in the model. So one way is to take sort of lessons from the model and apply them as in a general process. And the other is to use the model. And so one thing we learn from the model is that friction performance is very sensitive to contact area and to contact pressure. And so when people do finite element modeling, you can generate a heat map of contact pressure, and it will tell you the regions that have high contact pressure, which are also the regions that have poor performance. And so you can sort of look at that heat map, you can see the treads that are lit up red, and you can say, okay, those treads are maybe too high. Maybe those need to be lowered. The tread height of those need to be lowered to better distribute load to other treads.
I'm going to provoke here Rüdiger. Rüdiger, I'm always pleased, really, for me, it's a huge pleasure to be with guys like you in this kind of panels, because I'm remembering about a movie I saw very recently in Netflix, AlphaGo. If you haven't seen it in the weekend, if it's raining, try to go there. What's the importance in this movie? It's about artificial intelligence. So you have a set of guys that are playing a game that is above chess in complexity, and they start to play against the computer. And the computer is going to win a lot of times, because it's developing, it has artificial intelligence, and the computer is starting to understand different techniques to approach the game. And at the end, all humans that were competing against the computer and lost, some of them were deeply frustrated because they were world champions, have all become much better, and they have learned a lot by competing against artificial intelligence. And they understood that all this computational power that today we have in the pockets of our cell phones can put you even further in what you can achieve. And I believe this is going to be the mantra a little bit for every activity, and also for European safety shoe production. Are you in SYMPATEX already embedding some degree of artificial intelligence, of predictive models in the way you conceive your new articles, your new products, or is this still something that you don't feel you need?
I mean, let's give two answers to that question, because it is indeed provocative. The one is just applauding Kurt and also what you said, Pedro. I think if you come from an outsider with an engineering background, there's still a lot of space for simulation. And we developed the entire range of deep drawing process for waterproof booties, seamless waterproof booties, based on finite element models. So basically today, any client sends us the 3D model of his shaft, of the last, and within seconds, if not minutes, sometimes the calculation times takes up to a day, we can simulate the exact behavior of the various kind of laminates we have in the deep drawing process. We can predict the temperatures we need on the machine, the pressures, the vacuum, and so forth. So yes, there is a lot of space for that, and it's fantastic. On the other side, we need to be a bit careful in idealizing artificial intelligence, because if you drill it down to the root, the algorithms are programmed by humans. So artificial intelligence is in a way an accelerated way of interpretation of the guy who programmed it. And for example, if you would just take our industry, punch it in a computer program and say, optimize the ideal safety shoe, it probably would have a fantastic grip. It probably would be cost-wise quite okay. It probably would have all the safety features we need. But we might have forgotten there's one additional dimension coming into the entire equation, which is sustainability. The world is throwing away about 25 billion shoes a year, which is 7-8 times to the moon and back if you line them. And that's a mountain. And for a moment when Ambrogio was talking, I was just imagining that the Michelin tire company designs tires in a way that when you fix them on the car, you need to throw away the car when the tires run out. So there's definitely artificial intelligence and all this kind of optimization algorithms are fantastic if you know which way you want to go. But if you go new ways, and I think there's one huge dimension, and now it's hurting me to say because I'm an aerospace guy, but you mentioned at the beginning in TGV and Concorde and landing on the moon. But even as an aerospace guy, I need to say this was just an accelerated performance of what was already existing. We had slow trains, we made them faster. We had slow planes, we made them faster. What's in front of us is a complete reinvention of our industry as many others. The shoe, and we were talking grip, we were talking shafts, we were talking inner booty. The shoe is composed of different elements, which we try to make it to one. I think there will be a point when we need to reflect how we can dismantle them again, how we can make our industry modular again. And on this one, you probably won't find artificial intelligence, because artificial intelligence is an accelerated way of learning how to do things. In chess, it might help. In innovation, I don't think so.
Thank God. Rüdiger. So we still be needed as human beings. I
think we become even more important as human beings.
Yes, as I deeply share that point of view, and I'm very happy. Sometimes you feel you are alone in the desert, but having these guys sharing also this idea. And I wanted to share something with Ambrogio, because we work with Michelin, we produce also for JVI, and sometimes I believe European Union is trying to help by imposing norms. And the norms can avoid some misunderstandings in the market. You can avoid some proposals, some offerings to be considered equal when they are not equal at all. And since you have to pass the norms, well, you have a kind of a benchmark where you can compare. But on the other hand, sometimes I believe the norms also limit us. For instance, I would like to speak about in footwear, in safety footwear in Europe, it's being hard to bring the circular economy to us, the upcycling of the solutions. Why? Because materials have to have a certain performance. Materials have to respect a certain CADS and RICH level. And for instance, we have today possibility to include some rubber leftovers from other industries that perhaps we could work together to bring them to the market. But since the source of the rubber sometimes is not controlled, because these guys that reprocess rubber, that devulcanized rubber, can get it from bicycle tires, car tires, or different sources, the norm might not allow you to bring to the market something that you actually already master. And sometimes the norm can limit your innovation. Do you face this problem, Merlo, in your daily life? Do you think the norms are a way to improve what we can produce in Europe, or they can be, on the other side, also a limitation?
Honestly speaking, till now on the market, we are not facing front this kind of problem, but for sure, for the future, as I told before, the customer become more and more demanding of more sustainable product. As said Rüdiger, more and more the request on the market is to have product that can be recycled at the end of life. But as I told before, protection and performance is a must-have. Then our studied innovation for soles related to the working safety shoes is to create a new compound and a new design, a new technology in order to be able in the future to answer to this question, to use a recycled material, or more than that, to create a product that can be recycled at the end of life with a very low impact, but respecting the norms, because normally the norms are defined to warranty the protection and the safety of workers, but the real challenge is to respect and maybe to give a product that can be better than norms. And for us, it means give a product that can give a higher grip than the grip is given by the norm, higher comfort, less vibration transmission, and so, but using more sustainable material. Then, to answer to your question, today we don't have this problem on the table, but as normal for a company like Michelin, we are already studying solution for the future in order to respect these new requests coming from the market, more and more present around the world, because, as said Rüdiger, we have every year a mountains of shoes that we have to recycle in respecting the environment. Michelin is one of the leaders in the world in circular economics for tires, and for sure we work in the same direction for shoes. But in this field, we have to work together: designer, shoemaker, shoe brand, component supplier, and distribution network. We have to work all together with the same mentality in order to achieve these targets.
Again, Merlo, thank you for sharing your point of view, your idea. I am deeply convinced of what you said. And of course, the change, as Rüdiger said, the change has to start indoors. I believe we have to change the way we produce. We have to change the way we source our energy, the way we look to the leftovers of our productions. This will happen shortly. And also, as Merlo said, very important, to invite our customers and the partners in the design to think with us compatible solutions. A while ago, Rüdiger from SYMPATEX told us that he has to think about the circular economy and about the environment in every step he's taking along the way of creating a new product inside SYMPATEX. How do you deal inside Simplicity Works with this need to think processes and to cut the energy consumption and to cut the time to market? All of these difficulties, how do you think your tool can help us achieve those goals?
Well, I mean, the circular economy right now is a very important topic. This mindset of the cradle to cradle, let's say, just, to close the loop, is I think it's a very important goal. And in order to make it possible and real, there is a very important variable to take in consideration, which is the distance between the factory and the consumer. Because we shouldn't forget that the shoe will not obviously end in the factory, will be worn by the consumer, And somehow these goods, we tend or we dream to reinsert it again in the process. And that way, if we have our consumer or market close, obviously, we are able to bring then back those goods and work over the circular economy. I mean, in different ways. Either you recycle the parts, or you take care of the waste that could be created by the end product that won't be used again, right? So in that sense, any a concept of production that could facilitate the production locally somehow could enable maybe the circular economy in an efficient way.
Very well. I'm a keen adept of the technology that you have developed. I've already told you several times. I really believe that this is a jump into the future. And I believe that you have a lot of steel walls that you must cross over to be able to have the technology spread all over. Which are the difficulties that you face today that allow for a broad spread of the technology? Is it learning? Do the industrial guys need to learn how to interact with this tool? Is it about the mentality in the industry? What are the basic difficulties that you face today?
Well, when you want to completely change a paradigm of production, passing from an industry of almost 200 years based on the technology of stitching, if you want to switch from this to the other, you had to start from scratch. So before that the market switched to this new technology, companies like Simplicity Works had to develop absolutely, well, together obviously with the tech partners, absolutely every single detail of the technology. So this is a long process. If you see other technologies that have changed the world, we could bring many other examples over the table, whatever, the mobile phone or whatever, computer. Everything starts from an idea, and then after 8, 10, 12 years, start to be something known. As you know, the curve of innovation starts with the early adopters. I mean, first the innovators, the crazy ones, they just, try, fail.
We know the process.
So it's part of it's like in the world, they go in front, they fight, they want to just to get that feeling, which is great, but also they receive a
lot of punches back. Yes.
But then it comes another wave, let's say the early adopters, and then it becomes being massive. So it's just a natural process. Is nature, is evolution. It's like that. So and this process is really exciting. So we just obviously our job is to bring all the tooling, all the machines, all the learning, and to prove that this technology, it's simplifying the manufacturing. At the end, it will be implemented by itself. Talking about let's say the state of the art, right now we are in the industrialization phase with all new machinery, obviously with the same philosophy of injecting polyurethane, but having the full factory with all new equipment, a new philosophy of injection molding. So this is going to not only to change the way of making shoes, it's only to change the logistic inside the factory. So this is going to be presented the next year, and it will be an absolutely incredible breakthrough of injection processes. So that's what keeps us excited all the time.
It's nice to hear that. I remember when you and TOWORKFOR first met, and I was very happy to see you two companies joining forces and being the early adopters from concept and idea to materialization. And what have you learned? We are in the Safety Footwear Convention. What have you learned on the safety industry that you believe you can pass on to other industry adopting your technology?
Well, a safety industry is, let's say, is a good field for this kind of technologies. Actually, direct injection processes, they have a good penetration in safety footwear because there is obviously the tooling, design and manufacturing, and the tooling can be used for several seasons, several years. So the 3D bonding is not really far from direct injection. Is basically the same in terms of tooling and injection. So safety will be an important field of implementation. Just a few tips regarding why this technology can be really efficient for safety is, for instance, the way that the toe cap is integrated with the rest of the shoe. So it's part of it. The bonding process perfectly creates the match between the hardness of the toe cap and the flexibility of the upper, and in between there is the bonding material, which is the polyurethane. So, and also regarding comfort, as maybe I don't know if everybody is informed about how this 3D bonding technology works. We just this process is in how it works. We cut the parts, we put the upper parts inside a mold, three-dimensional mold, inserting it, leaving a space in between, and injecting a polyurethane that is bonding the parts by the edge. So the upper parts, they are attached in the same level. So that's why when you touch the product inside, it's smooth, there is no overlapping seams, so it's really comfortable.
It's like if you assemble a puzzle of pieces, you leave a small gap between the pieces and the polyurethane is going to bond them over in one macro structure, correct?
Exactly.
It's really a wise idea. Congratulations. I think you were...
It's simple, but it's a nightmare to develop.
Like everything that takes time and that brings our passion. That's a good sign. Something that I wanted to ask you about, in injection molding, we already use a lot of simul flow to help us simulate the behavior of the piece under injection, the behavior of the mold. We can fine-tune the injection points, the air vents, etc. Do you have access to this type of technology in your process, or is it more a learn as you do phase?
Yeah. Regarding, let's say, blowing polymers like polyurethane, there is limited access to software that can simulate that behavior, but it exists. Okay, so there is software that can simulate it. With this software, we learn what is going on there inside, right? Because there are things that you cannot even see it. I can give you an example. The way that the temperature in contact with the mold, just in the contact but not inside, is different. The flowability in contact with certain surfaces is different. So it's really well simulated with the software. However, obviously the trial and error, it is the only way to achieve the goals that we are doing it right now, and not only in injection, also about the bonding, the strength, so there are many variables involved in the process, and it's very much about trial and error as well.
Right now, if I could, I will read a short passage from Rüdiger book you wrote recently, because again, your idea really touched me, and I would like to hear your point of view, and then Kurt and Ambrogio, because we are here different guys. Everyone has a different point of view, a different need. But there is some column in what Rüdiger wrote. You said, and I will read what you wrote in your book, that another topic I'd like to raise with you comes from your public letter written on the outset of the corona crisis. As I told you, it takes a big chunk of courage to put it on a paper. And you explained that while outsourcing to new countries with low wages was considered an undisputed strategy for success in a global world, today the necessary regional measures to contain the infection are shaking each of these networks in an unpredictable way. We hope that suppliers, from whom we rested hard to reach price concessions yesterday with the arrogance of the stronger, will now continue to supply us despite all the local challenges. And we expect employees who were still meticulously monitoring until yesterday, instead of trusting them, to walk several extra miles for the company today in their home offices. This is true. And I hope people think about this. We have seen, and in ALOFT case, during this process, we were helped by a lot of partners, a lot of customers, and from different geographies. And this made me understand really the importance of this network inside and outside. Can you tell us a little bit more about what you wrote here? Because I really think it means a lot.
Yeah, so sometimes actually it drives me to put it out when it reaches a certain level of inner pressure. And this was in the context of the economic system we believe we need to act. I mean, we all embraced competition. We all embraced who can be faster. We all embraced who can be better. Like with the milk in our studies before we even went into industries. I mean, almost in kindergarten it starts. But when you look with a little bit of distance, what challenges are in front of us, it goes in a very different direction. I mean, we were talking now salts, we were talking shots. I mean, collaboration was not only needed for Concord, collaboration was needed for all, or will be needed for all the things which are in front of us, even to a level further. I mean, we're talking quickly circularity, and I'm a strong believer that circularity is like the only justification for any industry that is not built on pure grown harvestable resources. Then we need to understand how would a circular system look like? I mean, who's the customer and who's the supplier? And we played on this, especially in the apparel. We started in the apparel area. But when you look at a circular economy, everybody's at the same time customer and supplier to the same. So there's no supply chain. It's a supply circuit. And I think what is vitally important that we learn, and I think the crisis with all the drama and the like personal grief which is in there, and I can spend hours on it, but people spend hours on it. There's also an opportunity side. I mean, the Chinese word for crisis is threat and opportunity. And we need to look at the opportunity. And the opportunity, I think, in the first place is becoming aware that the way we optimize and the attitudes, how we optimize, will not lead us to the innovation. I mean, we're almost back to artificial intelligence. But I believe that algorithm of competitiveness only brings us to some point, but never in the new world we need to reinvent. And we need to become aware. And I think Corona has shown us in many regards, on one side, how dependent we are on that outer system, which we have neglected. I mean, we all know how many shoes we put out, but none of the companies is made accountable for the disasters ecologically that our products lead after the end consumers throw them away. Some might burn it, some might whatever, throw it in the garden of the neighbor, whatever. So I think this kind of reinvention of system will also require us to reflect how we interact with each other. And I think the Corona crisis just shows us the need for it, and at the same time, the almost myopic way we try to optimize things by just controlling them. I mean, we cannot control things. The world will drive in various directions, sometimes caused by like a microscopic virus at the moment. But what we can is understand what is the need of the future. And if we understand the need of the future, we also need to understand what kind of behaviors will help us to get there. And I think collaboration in this regard is probably the number one thing we need to really reflect. How do we interact with our colleagues? How we interact with our people? How we interact with our suppliers, with our customers? And that is, I mean, I'm a born optimist. I think that is the beauty of the future in front of us. If I talk circularity and the need for circularity, sometimes people freak out and say that's super crazy and dangerous and will disrupt our business and we will lose. And it's technically, especially in the shoe, it's really difficult. But if you just imagine the philosophical necessity for collaboration in a circular process, where everybody's at the same time supplier and customer of the same process, then it's fantastic, because we don't talk food chain and power battles anymore. We still will talk a challenge on speed of innovation, but not on a standalone, but in a fast collaborative way. And it will be a very unstable system, but it will be a very creative system. So that's why I put it out. I said, let's use the crisis also to reflect, not to bury ourselves in the measures to be short-termism to be done, but let's also reflect, will our ability and our philosophies and our approaches from the past help us in the future? And I think Corona shows us, no, we need to reinvent also the way we work together. And that's actually what we do now also with customers, where we clearly say, oh, let's have a dialogue. Here's a technology. We put certain things, we just put publicly out as an open source. All the circularity, sustainability intervention last 4 years, we all put them very rapidly out, and we ask everybody to copy it. There's no protection on it, because we believe when we reinvent, this can only be done jointly.
Rüdiger, thank you. I believe that what you say, a lot of people think that it is disruptive. And I have the impression that our grandparents were already doing it, but we have forgot how to collaborate. Even at the patent level, there is a certain, look to what Professor Kurt has done, what you have achieved, Kurt. It's something that it can be in a kind of an open source. We even discussed this. And then, of course, anyone can pick up and develop a special feature for himself. But why shouldn't this kind of knowledge be in a more open source platform again? It will allow us to be more economical, because it's very hard to invest money, everybody on the same time, trying to reach the same conclusion. So we can share costs and we can be faster on the market. Kurt, something for you. I don't know if you can talk about this or not. If you can't, just say so. I know that in the United States, the Army was also interested in the tool that you were developing to try to assess the performance, or at least I think I've understood this. Do you have any kind of governmental approach to this solution, to think about a better tool to predict behavior, or is this something that you have been more invited to study from companies in USA or elsewhere?
Can I ask? I'm not sure I understand the question. Is it?
So I will repeat. At a certain point, I remember reading something about your publications, and in one of the publications, but I don't know if that information is accurate or not, they said that the US Army was interested in what you were doing to try to see if the tool could assess the quality of their outsoles, etc. But I don't know if this information was accurate or not.
Yeah, so we have worked on a pretty limited basis with the U.S. Army to do some testing of their outsoles. That did not include the finite element analysis model that I discussed earlier.
Very well. Ambrogio, for you, about the safety footwear. The safety footwear market in Europe has been growing, but we are also seeing some consolidations. Well, how do you see the evolution of safety footwear here in Europe with European production in the next 10 years? Can you share a little bit your interpretation of what's happening?
Regarding the dimension of the market, we imagine that the market will increase a little bit in Europe, but not in an extreme way. But what it will change is the request of the market, the product will change in the future. Because, as I said before, the final consumer become more and more attentive to the quality of products and to the performance of products. But what I said before is just a little part of what it will happen in the future, because the extensive and widespread use of social media, now with that, now the final consumer really become the leading actor of the market. In this way, he can test the product, review the product, judge the product, promote the product or reject the product. Now, the companies can tell story if they are not able to maintain the promises. The final consumer today are me, are you, are everybody. I say the Rüdiger, we are in a circular environment. And then the consumer become what we call a prosumer, producer of contents and consumer in the same way. Then what I see is a complete change of product for the future because the prosumer will influence and inspire the future of safety footwear. If it will be, I say, an evolution in the direction of the European technologies for safety footwear or not, it will depend on us. It depends on the actors that create innovation in footwear. Because our mission is to answer, and maybe in anticipating the needs of the prosumer, and if we want to increase the local production, that could be a good idea also for, I say, the environment, to reduce for sure the transportation cost, and also to increase the respect of environment, because maybe in Europe we are more attentive in production than in some countries where the labor cost is too low. There are no rules or very open rules for the environment and so. But it depends on us. If all the actors that are in the innovation arena, the designer, the shoemaker, the shoe brand, the component supplier and the distribution network, we work together in order to create a circular environment of innovation in Europe, in order to develop sustainable technologies to produce the future of the safety shoes in a very, I say, in a right way to respect the environment and the circularity of the product, then I imagine that we can improve the quantity of production in Europe. It could be a good path if we work together in the right direction.
Thank you. The fact that brands are, and even producers like D2C, are starting to communicate much more with the final customer, the end user, on the internet, on LinkedIn, on the social media, is also affecting the way the end user, of course, wants to interact with his product. And for Rüdiger, this might give us a challenge. We have seen some cases in Portugal, more in the traditional shoemaking, where customization has brought together inefficiency and a lot of scrap level. We saw many people buying small hides, small skins, just to make a small piece, and then you have a big leftover. Adrian is going to talk a little bit his technology is aimed to sort that out, but I believe this is the customization can be a big challenge for the circularity. Can you give us a little bit your opinion over this topic?
I think there's definitely a risk. And conceptually, we need to really pay attention that we don't overstretch it, because customization of the individual shoe to the individual always carries the risk of inefficiency, also in the administrative process. On the other side, if we just take a little bit of distance, I think when we simplify the questions, we sometimes come up with very, very new solutions. So one of the simplified questions which led us to the thermoforming process was simply, well, we do great waterproof material and then we cut it and stitch it, so we make holes in it, and then it's not waterproof anymore, and then we fit it together and then we tape on it to make it waterproof again. So we do 2-3 steps in the process which destroys and repairs, which don't make sense. And we said, how can we combine it? The same thing with individualization. I think there should be a lot of brain we should put on developing technologies that can combine the two. We need to be very strict on the parameters. It cannot be that we individualize and increase wastage. But if you make clear boundaries, like, for example, we have done in a bootie, it's a monomaterial. So every cut off from the manufacturing process is recycled back into the yarn process because it's easily feasible. Technology is available, it's polyester based. And in this regards, we can even by today drive it down on the individual shoe size. We're actually currently working on a let's say, I almost said a modular, but it's actually a fully flexible last technology where we can actually adjust this last in the individual process. So the outcome would definitely be an individualized in a bootie for a shoe. Now, does that ultimately really make sense when you have an embedded flexibility in the material? I'm not too sure. Shall we jump on every customer idea? I'm not sure either. I think there needs to be two things. We need to respect the customer process, but innovation cannot always be driven by the customer process. If 150 years ago, we would have asked our customers what new type of transportation they would dream of, they would probably say, I want to have faster horses which eat less food, but nobody would have come up with a car or a TGV. So I think that is kind of, there's a part of where we need to respect the customer's priorities. There's a part where we need to be really creative. And I think there is even a third dimension, which is the constraints which simply out of the growth of humanity and the growth of industry we have on environmental level, we need to bring in as a constraint. And that's not necessarily coming from a customer. We cannot wait until the individual customer comes to us. This is our responsibility. So I think it's probably a combination of the three that can avoid that we go much further than we need to. I mean, if I ask waterproof material, people give me all kinds of water column levels. And when I investigated at the beginning of my job coming new in the industry, I realized the waterproofness people advertise now is sufficient if you put the hose of a fire brigade in water on you. I've never seen a rain like this anywhere in the world. So if we go too much over the limit, then we come what you also said on terms of norms and things where we just overstretch and cannot do the alternative requirements.
One of the points that Mr. Ambrogio Merlo from Michelin brought to us during this panel was the need to interact strongly with the final customers in order to improve our product. I believe you have a lot of interaction with your industrial customer, with your industrial partners. What about the end user? Do you get any feedback from the end user? How do you integrate the ideas that come from the end user, the normal guy wearing the shoes, into your development?
Well, the stronger connection is between the brand with our team. I mean, the designers, this is, let's say, the traditional process of the learning that they have already in their market segment. They bring it to us. They imagine the product accordingly with our guidelines. So we work together in order to create the shoe for that. Then after that, before going to the market, obviously we had to make a bunch of shoes for wear test. So we just spread some pairs in different markets, and then we do a wear test. Obviously, it is people not from the company, it's people outside. So it brings some very good feedback regarding comfort, resistance, and sometimes appears something that we never expect. I remember in one case we saw something that we couldn't imagine. So it's very good, because even you can not only improve the product by itself, also you can take care about any breakage or any technical problem that you in advance before making a large investment in whatever molding or molds. You make modifications and you make the best product possible.
Very well, Adrian. What would be your goals for the next 5 years? I'm checking here in the chat the questions that people are sending us. A lot of them ask us to have a kind of a crystal ball and ask us, where do you want to be in shoe manufacturing in 5 years? What will be your goal in 5 years for Simplicity Works with the Infinity technology?
Well, without mentioning numbers, I think we have an important goal, and it's creating the model of local for local with 3D bonding technology. And this is not only one factory working. This is a concept of integrating the supply chain massively and bringing the possibility for large corporations to produce again in Europe or in America. So there is we have one dream since years. This is called the Eco Challenge, and the Eco Challenge is very much similar to the car industry, where you have your supply chains integrated physically and digitally in a cluster, production cluster. So it is created to have a good cooperation and good synergy. So you can have different assembler, different companies, different footwear, maybe brands or a large assemblers, let's say in a central nucleus, which is surrounded by different companies, either raw material suppliers, or could be engineering companies, services, or mold makers, or software, and very important, recycling services. Because we had to be sometimes also critical with ourselves. I mean, I'm talking about we as people of the footwear industry. We try to create a more sustainable industry. Yes, all of us. But still the industry is having the same problems as X years. We are still cutting the leather and throwing away the waste. Then we can say that we are doing great things, but the basic things, we are not doing it. So instead of being island of companies trying to do some small efforts, if we group ourselves and all the waste that we create that can be immense in a big manufacturing hub, should be recycled by companies that are there for the purpose. So at the end, then we are creating our small circular economy.
Very well.
Which is much more simpler than sending the shoe far away and bringing it back. That it will not come back. So if we take care, it's like when you cook in your kitchen. I mean, the way that you cook. I mean, if you have everything clean, if you process everything, if you don't waste the extra food, if you don't throw it away, you know, we don't. Let's talk about the pretty basic things. So in that sense, the Eco Challenge, I think, is a big goal in the next 5 years. And hopefully when we meet at that time, it can be already through.
Thank you so much, Adrian. It's curious what you say. And I believe that we came into this panel discussing safety footwear, and all the speakers are bringing a little bit this big idea. We have to work more integrated. We have to work together if we want to create something new, something significant. And I'm convinced that you are taking a very important role on that one. Congratulations.
Thank you, Pedro. I mean, we know each other well.
Two crazy maniacs that are passionate about trying to change the world.
Yeah, and the way that we integrate ourselves, our ideas, is the energy that we obviously need to move forward. So I appreciate your effort doing these calls and organizing this event, because it's exactly what you are talking about, how we integrate each other to improve our industry.
Meanwhile, we are getting in our chat some questions that we would like to pose to the panel. Alexandra Dombrovska is asking us, the 3D printing, could it be a valid solution both for the shoe molds and for the ready outsoles? This is for Merlo. 3D printing solutions for molds or for final outsoles?
Yeah. 3D printing solution, for sure, we normally used in the development of soles. For the moment, we can also use the 3D printing to create some molds for some technologies, but not for compression rubber, but for other kind of polymer. For the moment, I think that this technology is not ready to create the soles itself, because the time to create soles at least the cost. But maybe in the future it could be possible. What I imagine is not so easy to reach also in the future with the 3D printing of soles is the level of performance that we can achieve today with some kind of specific compound in vulcanized rubber. But is a question of time, I imagine. Mm-hmm. Not for today, but maybe in the next future it will be possible. First, for molds.
Very well. I will connect this next question here to Professor Kurt. It is also about 3D printed molds, and this is something that we are already experiencing. We have done something like this in the past internally, and we have from Alexander asking us if do you believe 3D printed molds in aluminium will be more affordable in the future, and can we use them? So I believe our question is trying to understand if will 3D printed molds be cheaper in the future, and could, for instance, your software predict a design that we cannot mill, but we can 3D print?
Yeah, that's a great question. Yeah, it is definitely it is definitely possible. You know, I guess there are even more opportunities for 3D printed soles, because a 3D printed mold, you would still need to be able to, you know, pull the shoe outsole from the mold. So you would still have some limitations, but especially as we get to 3D printed shoes, there's opportunities to create voids in the tread, and you know, there are opportunities for, you know, as some treads wear away, for other tread channels to become revealed. So there are definitely possibilities as 3D printing technology evolves.
And then we have from Giuseppe Bettanini in Italy a question for Mr. Fox. In the future, what materials will be more relevant in the construction of technical shoes? What are the characteristics this material will need to have? Do you think leather will still have a relevant position in the building of safety shoes?
I mean, now you talk to somebody who just joined the industry 4 years ago. So I have a set opinion, but that opinion doesn't necessarily come from a technology point of view. If you look at the recyclability, reuse of materials, there's definitely a huge advantage across the board in any kinds of polyester materials. About 2/3 of the entire apparel industry is synthetic. About 70 to 80% is already polyester. So about half of any textile industry is polyester based. So I would say industrialization of recycling methods and circularity will come from that part. Now, from a technology point, that's for me a given. Leather is an interesting product because on one side it's natural. On the other side, the meat industry and the leather industry are always debating who takes what part of the CO2 footprint or the methane footprint on climate change. So I would say, is the leather the side product of the meat industry or the meat industry the side product of the leather industry? That will be determined by how much vegetarians will come up. I would say it's nothing bad about the product, but if you look at the processing or the generation process of leather, there is first of all the climate impact of the cow itself. There's definitely the treatment process, while there's still a huge level of chromium being used, and if you multiply this with the entire industry, it's still huge economic environmental problems. So I think what we need to learn is looking at these technical and material questions to look from two perspectives. One is what suits us best for the performance in the product, but on the other side, what are the downsides? What are the collateral damage we are creating? And in both upstream from a manufacturing process as much as downstream from a recycling process. So I think that is kind of thing we need to learn, and there won't be a straightforward answer. If plastic ends in the ocean, leather is definitely the better one. If plastic is in a circular process, it might actually synthetics being more advantageous than leather in the long run. You're muted, Pedro.
We thank you so much, Rüdiger. We have here a lot of people sending me questions in the side WhatsApp about either smart shoes. I'm not sure what they intend by smart shoes, if this is shoes with features like electronics, and we also have people speaking about smart materials. So on the smart materials, we have seen some metal structures, we have seen some polymeric structures that have, for instance, the ability to open porous structures to allow the steam to go out, to breathe, and when the temperature inside decreases, they will reclose, guaranteeing that your feet continue to be warm. We are aware of these materials. They have been there for quite a while. Typically, these are very expensive materials. Do you, in SYMPATEX, are you looking to this kind of solutions in smart materials at a broad level, or is this something very niche?
It's a straightforward no way, for two reasons. One, if you put electronics in any kind of products, it becomes an environmental challenge on any way after consumer. There are returning rules, so there are commercial challenges, there are definitely ecological challenges. So we clearly said the fixed combination of electronics, which is not a plug and play solution that can be dismantled easily, is not our territory. It's a yes with regards to thinking how we can emulate nature much better. I mean, our material has no porosity, and still through the combination of different kinds of polyesters and polyethers, we have achieved an active breathability. So that material doesn't need to be steered in a way, it reacts naturally in a way. And if we look in nature, there's so many examples we haven't really looked at. I mean, some buildings we built in white and black marble in Italy, why did people do it? Because it just accelerates a kind of airflow and cools down the building. So I think we sometimes make things much too complicated. And we create a problem in the first place and then create a problem by solving it again. And we have two problems at the end. So we try really to go as simple as we can. For example, when we looked at how we can build a simulation tool in finite elements, how to deep draw a shoe, we brainstormed until we came up and said, well, deep drawing a shoe thermoplastic deformation is nothing else than a reverse crash test. In a crash test, you take a car and run it against the wall in electronic means. And what we do, we take a flat surface and turn it into a form. Now we actually have a reverse crash test simulation program that is adjusted to the way. So let's think simple. A shoe has a few features, which is towards the ground to protect us from hurt. It has, perhaps as a safety shoe, some protection measures on the top. It has aesthetic requirements, and it has a comfort requirement for the fit. So we need to solve those issues the best we can, but I believe not to the detriment of putting now electronic. It might sound like a great marketing argument, and I bet you find a lot of consultants who go there. But when you really think it through, it just creates a bigger problem at the end.
Very well. Because we do get a lot of people asking us about what they call the digit sole, soles with a lot of digitalization, soles with a lot of features. Merlo, do you have customers approaching you about this 4.0 outsole full of features, full of technical wiring, or is this something that actually it's not coming to you in your everyday experience?
As you can imagine, we analyze all the news that's coming in the sole environment related to electronics, ideas, and so. But we can divide in two parts. One thing is to create testing soles and testing shoes, and then using electronics in order to detect performance and to analyze by instrument the difference between a behavior of one sole and another sole. Other thing, from our point of view, is to put electronics in every soles that is used every day. We see different ideas, different application and soles, but till now, what we have seen is more similar to a gadget, more similar to something related to marketing claim, and not really to a real advantage for the consumer, for the final user. In some cases, we have seen that people try to put inside of shoes functionality that not can be put in another part of clothes, but maybe adding complication. For example, someone is putting something in soles to detect the presence of the people in some area of the factory. But there is no reason to put in the soles. You can have just a bracelet, just something like that, without complication, because if you put electronic in the sole, you have to solve the problem to give the electric alimentation and so. What I want to say, electronics, I'm talking about today. Today, the state of art gives us some electronic device that can help us to create innovation and to evaluate the steps of innovation that we put in the soles to compare by instruments the evolution of performance. Other thing is the gadget that we see time to time. In this case, we evaluate that today, for this moment, we can classify that like a gadget, not like a real advantage for the final consumer that add complication, weight, and difficulties to use.
Thank you so much. And now a provocation to Kurt. Kurt, I have here plenty of people firing me to say, what about the role of the academia? What about the role in the university? Shouldn't they also support a little bit the burden of the circular economy and about the development of future solutions in the shoemaking? So I have here some guy saying that you guys from the university do not come to visit us in the factory with your ideas. I will allow you now to defend yourself, please, in the name of all the guys in the university around the world.
Well, first, I am happy to accept any invitation to go visit in the factory. So I'll get that out of the way first. But I would say that sustainability is it's not my topic, but it is a major focus point in academic research right now, and maybe the issue is maybe I need to connect with some of those people and bring them to the footwear world, because certainly the circular economy is a hot topic in universities, and if people in the footwear circles aren't seeing that, then they must be focused on other applications, and they probably just need to be steered into the footwear arena.
Very well. I like your defense. So guys, again, I'm really proud to be sharing these moments with you. It has been a tremendous pleasure to host you, to learn with you, because I believe the idea is to learn each other. And I also have a lot of people here live on the chat telling me that we should do more events like this all over. And this is part of, I think, what Rüdiger was speaking about, circular. Circular is about reaching for each other, touching hands, sharing more like we are doing here all over. It's the only way to create a solution, even during these COVID periods. Thank you guys. For me, it's a big honor. I'm really pleased, and I hope to speak with you all soon back again. So thank you. Thank you for your time and for staying tuned with us. We will still bring to you today a small pitch between ALOFT and Footwear Innovation Lab in Germany. We will present you the positive, negative outsole and how we achieve this. SYMPATEX will also share the atmospheric technology that they have developed, and they will have in a short pitch the explanation of how you can integrate these in your production, in your systems. BOA will also share the new features that they are bringing to the system, and we will close with the safety shoe development step by step inside TOWORKFOR AMF. Tomorrow, another interesting day. We will have the environmental panel. This is the correct closing for the system. We need to keep in mind all the upcycling of the ideas, all the upcycling of the materials, and I believe they will close with golden key this process. So tomorrow, it's a very important day. We need you. Come by. Ciao, ciao.